Hi there, welcome to Unit 1. In this lecture, we are going to introduce the divide and conquer strategy. This strategy is based on the concept that if the enemy is too strong, instead of fighting the whole army together, we try to split it and fight it one by one. So, in this case, what we do is, if we have a problem, instead of trying to solve the whole problem at once, we split the problem in two sub-problems, try to solve these sub-problems individually, and then find a common solution. This phase of here of dividing the problems in two sub-problems is what it's called the divide part of the strategy. Then the fact of trying to solve those problems is what we call conquer. And finally, the last phase would be just a combination. We call it combine. Of course, this is a simplification, but the division into sub-problems can be done as far as needed. We normally do this on a recursive way, that for each problem we divide it into two sub-problems, and each sub-problem we divide it into two new sub-problems until we arrive to a base case in which we can conquer it. So, as I was mentioned, the divide phase of the strategy is dividing the problem into sub-problems. Then we conquer the two problems recursively until they are small enough to be solvable when we achieve the base case. And finally, we combine the solutions to each sub-problem in order to form the final solution. Now let's try to see this with an example. If we have the Fibonacci sequence and we want to obtain a certain position of that sequence, what we can is divide the problem in the two sub-problems that will be computing the previous number and two previous numbers. Because if you remember, the Fibonacci sequence is achieved by averaging the numbers. The Fibonacci sequence always starts with 1 and 1, which those positions will be our base case, and then the next position is the result of making the add of the previous two. So that will be 1 plus 1, 2, then 2 plus 1, 3, 3 plus 1 plus 2, 5, so on and so forth. Therefore, the subdivision, the divide phase, can be simplified as computing the previous numbers. Conquering the case base is applying to those positions, and combining would be making the sum of those previous to those elements. So, given the Fibonacci sequence that I was mentioning, if we want to compute the fifth element, let's represent this as computing Fibonacci 5. We can simplify the problem to computing the previous two. That's it. Fibonacci 5 is equal to the numbers on position 4 plus number of position 3. And this can be repeated again. Position 4 is position 3 plus position 2. Position 3 would be position 2 plus position 1. And now here, the same. Position 2 plus 1. Here, as we have already established, this is a base case. We know this is the value 1, and the same for those two. So now the only thing we have conquered the problem, and we need to combine the solutions going up in the recursion tree. That means this would be the value 2, this is 2, this is 1, then this is 3, and 3 plus 2. Our solution is number 5. That's all. Thank you.